what I wanted to talk about was some of the basic principles and components of a commercial air handling system. These units can be rather large and complex. However, most of them will feature some of the basic principles that we're talking about today. This particular unit here is what we would call a return air system. We have a main supply fan for that system, represented by this graphic here. This is the part that actually pushes our air into the ductwork, which is then fed to the VAV system for this particular building. For more on that, check out the videos on my page about the basics of how a VAV reheat system works. We also have a return fan that serves kind of a dual function within this particular building. What this section does is actually draws air back from different parts of the building through the ductwork, and either uses part of that air or returns that air back through the supply fan side of the unit, or if we are economizing, it will exhaust out the excess air to maintain the correct building pressure. This section here, this set of dampers, as well as these two sets here, are representative of dampers that are used in the economizer mode, as well as our mixed air, as well as exhaust. When we are economizing, when we are using outside air basically to cool the building instead of using our chiller system, you're bringing in a large volume of air into that building. One of the things this will do is actually pressurize the building. So when we bring air in to a building like this, we also have to exhaust out a specific amount of air as well to keep the building from going too positive. That can cause your doors to stand open and a lot of other issues. This mixed air section here will basically control the amount of air that is returned to the supply fan section to be reused within the building, and or to exhaust out the excess pressure if we are economizing. Now, generally, most buildings will have a minimum amount of outside air that they bring in. This is done to help control the CO2 levels within the building. If you do not bring in fresh air, you will get high CO2 in the building, and people will basically just get sleepy. So by maintaining a minimum amount of outside air, you will help keep enough air coming in to keep the space supplied with viable air. Now then, this unit here, the basic function of the unit, we see a hot water coil for this unit. We also see a chilled water coil for this unit. When we are trying to maintain a specific discharge set point, the air handler will control using the dampers as well as the heating and cooling coil to maintain a specific discharge temperature. It is more efficient in cooler days, cooler weather, to use outside air to cool your building. However, whenever the temperature is too high outside, when we are running our chillers, we will need a way of cooling the air, both the minimum amount of air from the outside as well as the return air from the building, down to the correct temperature for effective cooling. There can be times as well, if the air is too cold, that we will need to heat up the air using the hot water coil. It is, again, this type of system is supplied either by a boiler or steam for hot water. And we have our large chiller system that supplies our cold water for the chilled water coil. This particular air handler here features a type of system that is static pressure control. You can read more about that on my blog at systemcontroltech.com. Basically, there is a variable frequency drive that will either speed up the motor or slow it down depending on the static pressure set point. If we have a lot of VAVs that are open, that are calling for more air into the space, the pressure inside the ductwork will drop. Then the VFD will increase its speed to try to maintain the static pressure set point. If we overshoot our static pressure set point when a lot of the rooms go unoccupied, or if they become satisfied with air, with the airflow that they're receiving, the drive will then back down until our pressure reaches its set point level again. When we look at this unit here, we will see that we also have a lot of temperature readings. We have our position of our dampers, depending on what we're going to be calling for, whether it is using a lot of mixed air or outside air. So this unit can really tell us a lot about what is going on inside of it. It really helps us in troubleshooting. Now, one of the things that you can look at here in your mixed air section, when a day is real warm, when it's real hot outside and we are using our chiller system, it is much more energy efficient to use the return air from the building that has already been cooled that has already been cooled, and recirculate it through your air handler system back into the building. Of course, you're going to be adding a minimum amount of outside air to maintain your CO2 levels. This type of system is very, very useful and very common for a lot of commercial and industrial applications.